All right, welcome. Today, we are going to tear apart a classic GCSE computer science question about the CPU. And my goal here is super simple. I want to show you exactly how to walk out of that exam with every single mark for this question locked down.
Okay, so let's take a look. This is the question. It's asking you to name two registers from the fetch-execute cycle and then explain what they do. Now, it looks pretty straightforward, right? But these 4 marks can genuinely be the difference between great boundaries, so let's make sure we get every single one.
First things first, we need to get inside the examiner's head. What are they really looking for? Well, it's 2 very specific things for each row: the correct name of a register from the fetch-execute cycle and a super precise description of its job.
Think of it like a little game. For each register you pick, you get 1 mark just for naming it right. You get a second mark for defining its purpose perfectly. So, 2 registers, 2 marks each. That's our 4 marks. We're going to build this answer step by step.
So, for our first register, let's go with a real heavyweight, the one that basically runs the whole show, the program counter, or PC. You absolutely want to have this one in your back pocket for the exam.
Okay, now lean in, because this is the most important part. Look at that wording. Stores the address of the next instruction to be fetched. That isn't just a way to describe it. That is the exact wording from the official mark scheme. Memorizing this phrase is literally the key to getting that mark.
And to help that definition stick, just picture the program counter as a little signpost inside the CPU. It's always pointing to the next thing on the to-do list. The second one job is done, that signpost immediately swings around to point to the next one.
Right, we've got 1 down. Let's move on to our second register, which actually works very closely with the program counter. We're going to go with the memory address register, or MAR.
And again, look very carefully at this definition. Stores the address where data or an instruction is to be fetched from or stored to. Just like with the PC, this is the golden phrase. This is the precise mark scheme approved language. You use this, you get the mark. Simple as that.
So, let's think about our analogies. If the program counter is the signpost pointing to the next general area, the memory address register is like dropping a pin on a map. It holds the exact location, the specific address in memory that the CPU needs to go to right now.
Okay, perfect. We have our 2 registers. We have their word-for-word mark scheme perfect definitions. Now it's time to put it all together and build that full 4-mark answer. And there it is. This is what it looks like. In the exam, you'd write program counter in the first column, its exact purpose in the second. Then you do the same thing for the memory address register on the line below. It's clean, it's precise, and it is a guaranteed 4 marks.
And that's really the whole trick. By picking these 2 registers and using their exact definitions, you've done everything the examiner is looking for. You've ticked every box on their mark scheme. That is 4 out of 4 marks, safe in the bag. Job done.
But hang on a second. What if you get into the exam and your mind goes completely blank? You can't remember the PC or the MR. Don't panic. The great thing here is that the mark scheme actually allows for other correct answers. It's always smart to have a couple of backups ready to go.
For example, you could whip out the memory data register, the MDR. It's the temporary holding bay for the actual data that's just been grabbed from memory. Or you could use the accumulator, the ACC, which is where the results of all the math from the ALU get stored. Both of these are totally valid options to get you those marks.
So at the end of the day, this all comes down to one thing: precision. Yeah, knowing what the program counter does is great, but being able to write down its purpose using the exact language the examiner has on their checklist, that is what turns a good answer into a perfect full-mark answer.
So there you have it, a complete game plan to absolutely nail this type of CPU question. You've got these registers down now, so the real question is, what's next? The control unit? The ALU? Whatever it is, take this momentum and keep that revision rolling.